How does ISRO use geosynchronous transfer orbit, GTO, for satellites? Imagine launching a satellite into space and having it reach its final spot in the sky with just the right speed and position. That's where the geosynchronous transfer orbit, or GTO, comes into play. ISRO, India's space agency, uses GTO as a vital step to place satellites into their correct orbit. These satellites are often used for communication, weather monitoring, and navigation because they stay fixed over the same part of Earth. A GTO is an elliptical or oval-shaped path that starts close to Earth and stretches out to the altitude where the satellite will eventually operate. Instead of sending a satellite directly into its final orbit, which would need a lot of fuel, ISRO's rockets first place the satellite into GTO. From there, the satellite uses its own onboard engines to make small adjustments and move into a circular geostationary orbit. ISRO's main launch vehicles, the Geosynchronous Satellite Launch Vehicle and the Launch Vehicle Mark III, are designed to carry heavy payloads, up to 4,000 kilograms, into GTO. These rockets have multiple stages, including solid, liquid, and cryogenic engines, which work together to push the satellite into space. The final stage provides the boost needed to reach GTO, after which the satellite's onboard engines take over. Once in GTO, the satellite performs engine burns to raise its lowest point, called perigee, and lower its highest point, called apogee. This process gradually moves the satellite into its final geostationary orbit, where it appears to stay still over one spot on Earth. This method is efficient and saves fuel because it avoids the need to send the satellite directly into its final orbit in one go. ISRO's use of GTO is similar to how astronauts train in stages. They learn each step carefully, practicing and mastering each before moving on. Launching into GTO is a big milestone for a satellite, much like how astronauts complete training simulations before a space mission. The entire process requires precise planning, teamwork, and careful execution, which ISRO has become very skilled at. Using GTO allows ISRO to launch heavier satellites more cost-effectively, supporting India's growing needs in communication, navigation, and Earth observation. It also reduces the risk of failure because each step can be monitored and adjusted if needed. This approach makes space missions safer and more reliable, helping ISRO continue to grow as a major space organization in the future.